You've heard the story 1,000 times. In the beginning, there was nothing. Then bang, the universe began expanding 13.8 billion years ago. But here's what nobody tells you. That story makes absolutely no sense. Not philosophically, physically. The math breaks down completely. At the moment of the Big Bang, our equations produce infinities, which in physics means we've hit a wall. We don't know what we're talking about anymore. So what if the Big Bang wasn't the beginning at all? What if it was just Tuesday? Let's start with what we actually know, not what we think we know. When you hear Big Bang, you probably picture an explosion, some cosmic firecracker going off in empty space. But that's completely wrong. The Big Bang wasn't an explosion in space, it was space itself being created, and time too. Before the Big Bang, there wasn't an empty void just sitting around waiting. There wasn't a before at all because time didn't exist. Think about it this way, you're watching a movie and you ask what happened before the opening credits. Well, nothing happened before the opening credits. That's when the movie started. According to traditional Big Bang theory, asking what happened before the Big Bang is like asking what's north of the North Pole. The question doesn't make sense because you've reached the edge of the map. But here's where it gets weird. When physicists try to trace the universe backward in time, they can go pretty far. We can rewind to when the first protons and neutrons formed. That happened about 1/10,000th of a second after the Big Bang. We can go back further to when the universe was just a soup of fundamental particles. We can even go back to when forces that are separate today were all unified into one. But then we hit a wall. As we approach time zero, the moment of the Big Bang itself, something impossible happens. The density of the universe becomes infinite. The temperature becomes infinite. The curvature of space-time becomes infinite. Physicists call this a singularity, and whenever you see infinity pop up in your equations, it's nature's way of saying, your theories don't work here anymore. So what's really happening? You need to understand something counterintuitive about physics. Our current theories have expiration dates. Think of it like a map. If you're driving around your city, a street map works perfectly. But if you want to fly to another continent, that same street map becomes useless. You need a completely different kind of map. Our current physics works brilliantly for most of the universe, but it breaks down under extreme conditions. Einstein's general relativity, our best theory of gravity and space-time, works beautifully for describing huge things like galaxies and the expansion of the universe. Quantum mechanics, our theory of the very small, perfectly describes atoms, particles, and all the weird behavior of matter at tiny scales. But here's the problem. These two theories hate each other. They give completely different answers when you try to use them together. And guess where you absolutely need to use them together? At the Big Bang. You've got all the mass and energy of the entire universe crammed into a space smaller than an atom. That's quantum mechanics territory. But you've also got gravity so intense it's warping space-time into knots. That's general relativity territory. Put them together, and your equations basically throw up their hands and quit. This is why physicists are desperate for a theory of quantum gravity, something that can handle both the very small and the very massive at the same time. String theory is one of the major candidates, though it's not the only approach. Now, string theory gets a bad reputation because it's incredibly complex and hard to test. But here's what it does. It has the potential to eliminate those infinities. In string theory, particles aren't tiny dots, they're tiny vibrating strings. This seemingly small change has huge consequences. When you redo the Big Bang calculations with string theory approaches, some models suggest the singularity could disappear entirely. Instead of infinite density, you get very high but finite density. Instead of the universe starting from nothing, you get, well, that's where things get really interesting. In some string theory models, what we call the Big Bang might actually be a big bounce. Picture a basketball bouncing on the ground. The moment it hits the floor and starts going back up, that's our Big Bang. But the basketball existed before it hit the ground, didn't it? This leads to what physicists call the ekpyrotic universe. In this scenario, our universe might be just one cycle in an eternal process of expansion and contraction. Before our Big Bang, there was a previous universe that was contracting, getting smaller and denser until it reached some minimum size, then bounced back out in what we experience as the Big Bang. But there's another possibility that's even stranger. Maybe the universe literally popped into existence from nothing. Not nothing like empty space, actual nothing. No space, no time, no matter, no energy. Quantum mechanics tells us that even in perfect emptiness, particles can spontaneously appear and disappear. These are called quantum fluctuations, and they happen all the time at microscopic scales. Some physicists, like Alexander Vilenkin at Tufts University, have shown mathematically that the entire universe could be one giant quantum fluctuation. In quantum mechanics, you don't need a cause for something to happen. You just need a probability. There's some tiny but real probability that a universe could just pop into existence, the same way particles pop in and out of existence in empty space. This sounds insane, but it's actually testable. Here's how. If the universe bounced from a previous contracting phase, that bounce would leave specific fingerprints in the cosmic microwave background, the afterglow of the Big Bang that we can still detect today. If the universe popped into existence from nothing, it would leave different fingerprints. Think of it like forensic science. A detective can't witness a crime, but they can examine the evidence left behind and figure out what happened. Cosmologists are cosmic detectives, looking for evidence of what happened before our universe began. The key is something called primordial standard clocks. These are heavy particles that should have existed in the very early universe, oscillating at regular frequencies like the ticking of a clock. Different theories about what happened before the Big Bang predict different patterns of these clock ticks, and those patterns should be stamped into the structure of the universe we see today. Recent research from the Harvard-Smithsonian Center for Astrophysics has laid out exactly how to look for these patterns. If we can detect them, we might be able to peer back beyond the Big Bang itself, not with telescopes, but with mathematics and detective work. But here's where it gets philosophically weird. Some physicists argue that asking what happened before the Big Bang is fundamentally meaningless. Stephen Hawking famously compared it to asking what's south of the South Pole. If time itself began at the Big Bang, then before doesn't mean anything. Others disagree. They point out that just because our current understanding of time breaks down doesn't mean time itself stops making sense. Maybe we just need better concepts, better mathematics, better theories. Why should you care about something that happened or didn't happen billions of years before you were born? Because this question touches the deepest mystery of existence. Why is there something rather than nothing? Every atom in your body was forged in the heart of a star or in the first few minutes after the Big Bang. The calcium in your bones, the iron in your blood, the oxygen you're breathing right now, all of it traces back to that moment when the universe began. Understanding what happened before the Big Bang isn't just about cosmic history, it's about understanding where everything you are came from. But there's a more immediate reason to care. This research is pushing human knowledge in ways that could revolutionize technology. Quantum mechanics seemed like pure, abstract theory when it was developed, and it gave us computers, lasers, MRI machines, and GPS satellites. String theory and quantum gravity might seem impossibly abstract now, but they could unlock technologies we can't even imagine. Think about it. If we figure out how to manipulate space-time at the quantum level, we might discover new forms of energy, new ways to travel, maybe even new ways to exist. The physicists working on these problems today are laying the groundwork for discoveries that could transform human civilization. And there's something profound about the fact that we can even ask these questions. We're made of star stuff, arranged in such a way that the universe can think about its own origins. We're the universe's way of looking back at itself and wondering where it came from. That's not just scientifically remarkable, it's almost miraculous. The search for what happened before the Big Bang is really the search for our deepest roots. It's the ultimate genealogy project, tracing our family tree not just back to our ancestors, but back to the very beginning of everything. Whether that beginning was a bounce from a previous universe, a quantum fluctuation from nothing, or something we haven't even thought of yet, the answer will tell us something fundamental about what it means to exist. So what happened before the Big Bang? The honest answer is we don't know yet, but we're closer to finding out than ever before. The Big Bang might have been the beginning of everything, or it might have been just another Tuesday in an eternal cycle of cosmic bounces. The universe might have popped into existence from absolutely nothing, or it might be one bubble in an infinite foam of universes we'll never see. What we do know is that the question isn't meaningless. The math is getting better, the theories are getting more sophisticated, and the evidence is starting to come in. Within the next decade or two, we might finally have an answer to the biggest question humans have ever asked. Where did everything come from? And when we find out, it's going to change everything we thought we knew about reality itself.